All right, let's jump right in. Today, we're going to pull back the curtain on the invisible architecture that makes our entire digital world tick. We're talking about the OSI model, which is basically the universal rulebook for how all digital communication happens. I mean, have you ever really stopped to wonder about the absolute magic that happens when you send a message or load a website? How does your phone, right there in your hand, talk flawlessly to a server that could be on the other side of the planet? It feels instantaneous, right? But it's not magic. It's an incredible, perfectly standardized process that's working behind the scenes. And the answer to how it all works is the OSI model. Now, this thing was developed way back in 1984, but it's still fundamentally important. It's a conceptual framework, think of it as a universal blueprint, that takes the massive, complex job of network communication and breaks it down into 7 distinct, manageable layers. And here's the kicker. Every device, everywhere, has to follow these rules. Okay, so to really get our heads around this, the best analogy is to think of it like a super efficient digital postal service. It's a perfect comparison. Your data, that photo you're posting, that email you're sending, that's the letter. The OSI model, that's the entire postal system, from the moment you write the letter to the second it gets put on the delivery truck. This whole process of getting your data ready to send has a fancy name, encapsulation. But really, it's just wrapping the data in layers of instructions. It all starts at the top. At the application, presentation, and session layers, you're basically just writing your letter, maybe translating it for security, and sealing it in an envelope. Then, layer 4, the transport layer, does something really clever. It breaks your big letter into smaller, numbered boxes to make shipping easier. Next up, layer 3, the network layer, slaps on the final destination address, the city, the zip code. Then, layer 2, the data link layer, adds the instructions for just the next stop on the journey. And finally, layer 1, the physical layer. That's where the rubber meets the road, literally, putting the package on the truck as raw electrical signals or light pulses. Now let's pause for a second on layer 4, the transport layer, because this is where a really crucial decision gets made. It's like you're standing at the post office counter and you have to choose your delivery service. Do you need guaranteed sign-for delivery, or is fast and simple good enough? And that choice really boils down to 2 options you've probably heard of, TCP and UDP. TCP is your premium, sign-for-delivery service. It makes a connection, it checks to make sure every single one of those little boxes arrives and that they're all in the right order. It's absolutely critical for things like loading a web page. Then you've got UDP. Think of UDP as a postcard. It's way faster because you just send it off and hope for the best. It's perfect for things like video streaming or online gaming, where speed is everything, and losing a single tiny pixel here or there doesn't really matter. Okay, so moving down to layer 3, the network layer. This is where every one of those little boxes gets its global address. We're talking about the IP address. This is the big picture address, like the zip code for the entire internet that tells routers all over the world where this data ultimately needs to go. But wait, how does the package get from your router to the next router down the street? That's where layer 2 is so smart. It adds a MAC address. Think of the MAC address as the very specific street address for the immediate next hop in the chain. So the IP address is the final destination city, and the MAC address is the address of the next post office on the route. All right, I know what you're thinking. 7 layers. That's a lot to keep straight in your head. So how do network engineers actually remember all this? Well, they use a simple, kind of silly little trick. A mnemonic device that, believe it or not, involves pizza. Here it is. We're going to learn the layers from the bottom up, from layer 1 to 7. Just remember this sentence. Please do not throw sausage pizza away. Physical, data link, network, transport, session, presentation, application. See? It's a classic for a reason. And you can see right here how our little pizza mnemonic lines up perfectly with the whole stack. From please at the bottom, the physical layer, dealing with raw bits, all the way up to away, the application layer, which is what your web browser actually talks to. Each layer has its own specific job and even its own name for the chunk of data it's handling. So our package has traveled across the internet and it's finally arrived at its destination. The receiving computer now does the exact opposite of everything we just did. It's time for the unboxing. The official name is decapsulation. It starts at the bottom at layer 1 and just unwraps each layer of instructions we added, peeling off the local address, then the global address, then reassembling the boxes, until it's left with the original, pure data. Okay, now for a quick reality check. While the 7-layer OSI model is the perfect blueprint for learning about networking, the actual real-world internet runs on a more streamlined model called TCP/IP. You can see how it basically just squishes some of the OSI layers together. The top three become a single application layer, and the bottom two become a network access layer. It's a more practical, condensed version of the same core concepts.
And that leads to a really good question. If the internet actually runs on the simpler TCP/IP model, why on earth do we spend so much time learning this 7-layer OSI model from 1984? Why does it still matter?
The answer is simple. It is the ultimate diagnostic and educational tool. It gives everyone a universal language. So when something goes wrong, an engineer can ask, is it a layer 1 physical problem, like an unplugged cable, or is it a layer 3 routing problem? It also allows different companies to build hardware that all works together seamlessly. And most importantly, it is still the absolute best way to learn networking concepts from the ground up. So let's bring this all home with a real-world example. Every single time you browse a secure website, this entire 7-layer dance happens in the blink of an eye. Your browser uses HTTPS at the application layer. The data gets encrypted at the presentation layer. A session is opened. Good old TCP at the transport layer makes sure every piece of the website arrives. IP routing at the network layer finds the server anywhere on the planet. And finally, Ethernet or Wi-Fi handles the local journey over physical wires or the airwaves. It's happening constantly, right under our noses.
So, the OSI model has been the foundational blueprint for our digital world for nearly 4 decades. It's an incredible testament to solid, forward-thinking design. But it leaves us with a fascinating question to chew on. As we move into a new age of AI, quantum computing, and the Internet of Things, what might a blueprint for tomorrow's Internet need to look like?